Welcome to the series finale of the Working Thesis. Over the last 9 episodes, we have looked at the brain in the jar, the harness that acts as its body, the landscape of tools, and the deep source code choices that bind them together. Today, we bring it all home. Literally.
The number one question we hear from developers is, can I run all of this locally? No cloud APIs, no subscriptions, just my code and my hardware. They want to know if they can host the brain and the body entirely on their own machine.
The short answer is yes, but the long answer is that running a highly capable coding agent entirely on your own machine requires you to understand the concept of natural couples. You cannot just pick a random model off the internet and a random harness and expect magic. You have to match them perfectly.
Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself.
A natural couple is when a model and a harness are effectively designed for each other. Increasingly, this is becoming a training time decision. Model makers do not just train a model in a vacuum anymore. They tune it against a specific harness and ship the pairing.
Exactly. For example, you have gpt-oss paired with the Codex CLI, specifically using the Harmony or Responses tool format. You have Devstral paired with OpenHands, which was built through a tight collaboration between Mistral AI and All Hands AI. And you have Qwen Coder paired with Qwen Code. Though to be fair, Qwen Coder also works exceptionally well with OpenCode and Cline.
These are not exclusive locked-in partnerships, but they are highly optimized. When you pair Devstral with OpenHands, you are pairing a brain and a body that were quite literally raised together. They speak the exact same dialect of tool calling, which eliminates so much friction.
This brings us back to the governing rule we established back in episodes 6 and 7. You have to match the demands of the harness to the strengths of the model.
Fully autonomous harnesses, the ones that want to run a complex agentic loop without your help, demand incredibly strong tool calling, flawless instruction following, and massive long context windows. These are exactly the areas where smaller, local models are historically the weakest.
Right. So you really have two distinct choices for a local setup. Option 1, you pick a model that was explicitly co-trained for agentic tool use, like the natural couples we just mentioned. Option 2, you pick a harness that demands far less from the model. You pick a highly forgiving harness, like Aider.
But before we recommend specific setups, we have to talk about the physical reality of home hardware. Let's say you have a high-end workstation, like an NVIDIA DGX Spark, as of 2026.
The DGX Spark has about 128 gigabytes of unified memory. That sounds absolutely huge. You might think, great, I can load a massive dense model into memory and let it run the agentic loop flawlessly.
It will fit in memory, yes. But here's the brutal reality. Memory bandwidth is the real bottleneck. The Spark has roughly 273 gigabytes per second of memory bandwidth. When you run a massive dense model, every single parameter has to be read from memory for every single token generated.
Which means that big dense model will fit, but it will crawl. It might output only a few tokens per second. In a chat window, you might have the patience for that. But an autonomous loop requires thousands of tokens of hidden thought process per lap. A few tokens per second is simply too slow for an autonomous agent to be useful.
This bandwidth bottleneck is exactly why mixture of experts, or MOE models, and heavily optimized smaller models are winning the local game.
With an MOE model, even if the total model size on disk is massive, only a few billion parameters are active during any given token generation. You are not bottlenecked by that 273 gigabytes per second of memory bandwidth because you are not reading the entire model on every single token.
So a local MOE model, or a highly efficient dense model, runs incredibly fast. It generates tokens rapidly enough to support the hidden thoughts, the tool calls, and the context compaction required by the agentic loop without making you wait an hour for a single file edit.
So, what should you actually run today? If you want the most reliable, just works local setup, we recommend Aider paired with a local coding model running on something like Ollama. Aider asks very little of the model regarding strict JSON formatting, and it leans on a cheap, highly efficient repo map.
If you want a real, fully autonomous local agent, you need to go with a natural couple. You can use gpt-oss with the Codex CLI in its open source mode. You can use Qwen Code with OpenCode or Cline. Or you can use Devstral with OpenHands.
And what should you avoid? You can safely skip tools like Qwen Code or other cloud-brokered tools for your local setup. They are incredible tools, but they are hardwired to cloud APIs. They simply cannot drive your local, home-hosted model.
We are clearly moving toward an incredible future here. The emerging, aspirational dream that the industry is pushing toward is what we call self-driving upgrades.
Imagine a lightweight local harness that just sits in the background of your machine as a daemon. While you are sleeping, it runs a fast MOE model, reads your codebase, finds outdated libraries, refactors messy functions, and queues up a clean pull request for you to review in the morning.
It is the ultimate expression of the autonomous loop. It requires no human prompting to start. The harness manages the environment, and the local model provides the cheap, fast reasoning. We are not fully there yet in everyday production, but that is exactly where this technology is heading.
And that brings us to the end of our journey. We started this series by looking at a stateless brain in a jar, an LLM that could predict words but could not actually do anything.
We saw how the harness acts as the body, providing durable memory, tools, and the agentic loop. We explored how compaction keeps the brain focused, what makes a coding model genuinely good, and how the landscape has converged on a shared grammar.
We saw the profound impact of how edits are formatted, and today we brought those brains and bodies to your local hardware.
The biggest takeaway from this entire series is this. The model thinks, but the harness acts. They are two halves of the same machine. And now, you can finally see inside the magic.
Thank you so much for joining us on this deep dive. Keep building, keep verifying, and we will see you out there.
And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.